what we've been doing over the past couple of years is developing living evidence maps of what work to address inequalities in primary care. And so this is what it looks like, and I'm going to unpack it over the next 30 to 40 minutes. So these evidence maps break down different disadvantaged groups and different types of healthcare primary care interventions, with each circle representing either an umbrella review or a systematic review. So we've got lots of different types of disadvantaged groups and lots of different primary care interventions. So if, for example, we're interested in ethnicity and screening, we can click on the number of records and it gives us all the systematic reviews related to ethnicity and screening. And I'll show down here in a moment. And we created a series of these evidence maps using machine learning, and they're living in the sense that they get updated every month with new articles. So this is where we're going with this talk. I'm going to unpack about how we produced this and what it looks like, and I'll show you a few more of these maps towards the end of the talk. So I'm now going to switch to a PowerPoint presentation and just show you how we got there. So hopefully you can see that. So before I start, just a quick shout out to the people who've been integral to the delivery of this. So first of all, we've worked a lot with EPPI Centre GCL, particularly Ian Shemilt, who's helped us with a lot of the AI machine, but also our team both here at QMUL, so Ophelia and Cam, Helen Cambridge, Becky, who's been doing all of our comms, and Hex Productions, who's done our web design. Yeah. So the background to this project is that we received about 300k of funding from NHS England, East of England team. At the minute, there's some background noise, so I don't know if everyone's muted or not, but yeah, that's better, thanks. So the background to this is we received about 300k from NHS England, East of England team for an 18-month project to do three main things. One is create these living evidence maps. I've shown you what the end product looks like, and that's driven by machine learning. Another one to look at some data for ICBs and to pull this all together in an online hub and resource centre. So that's all we were given the money to do, and today we're just going to focus on that. First part is how we create these living evidence maps. So the plan for the next 25-30 minutes is first of all to talk about, why do we need to automate the systematic review process? And then I'm going to go into a bit of detail about how it works, and I'll give another bit of a live demonstration and then touch on future plans.
You've muted yourself, John.
Thank you. So I'm hoping I haven't muted myself for too long, but I'll pick up here. So I started my career working for NICE. So I was part of the University of Aberdeen Evidence Review Group. So every time a new drug was proposed for the use within the NHS, we would do a big systematic review of the clinical and cost effectiveness of that drug. And that was about 14 years ago or so. And we went through this process, as I'm sure most of us who've ever done a systematic review have been through, going through design a research question, usually using something like PICO, then designing a search strategy, mainline, Embase, Web of Science, whatever. Then there's this tedious process of screening titles and abstracts. And then once we've screened the titles and abstracts, we've got a list of potentially included studies. We then look through the full text of those studies. We extract what we want out of those included studies. Then there's a process of synthesizing the data. And if we do the statistical pooling of results, we do a meta-analysis. We then write that up, submit it to a journal, forget about it for a few months, then deal with peer review comments, and finally publish it and disseminate it. So this is the traditional way of doing systematic reviews. It's been like this for decades. There's a few problems with this process. One is it takes a long time. So the length of time on average between designing the research question and finally publishing results is about 16 months. That doesn't build in any time if you have to secure funding. So certainly for the most recent NHR funded research review we've done, it took about 18 months for us to write a grant application and to get funding. So it can take up to 3 years between conceptual an idea and finally publishing something. So they take a long time. And obviously, if we're trying to influence policy and practice, sometimes, quite often, policy priorities change, and they don't have 18 months to wait for a review. Second problem is they take a lot of effort. So this is an example of a systematic review where they looked at the risk of dementia and chronic cognitive impairment after traumatic brain injury. That's where I'm hoping none of the people in the call are authors. Anyway, in this review, what they did was they did the search strategy. When they did the search strategy, they identified over 77,000 hits. So when they did Medline, Embase, Web of Science, and their other electronic databases, they had 77,000 hits. And from those 77,000 hits, they identified about 300 articles. From those 300 articles, we identified 100 articles which met their methodological quality threshold. And from those 100 articles, there was 8 articles which looked at either dementia or chronic cognitive impairment. So they screened over 77,000 to end up with 8 articles. When I was doing screening, we used to work out about 500 a day. But to do it 77,000, that's going to be screening non-stop every day for about 8 months to get 8 articles. So it takes a lot of time and effort. And I'm not suggesting most reviews have that number of hits, but you can understand that even if it's a seventh of that 10,000, it still takes a long time to go through screening all those titles and abstracts, and the returns can often be modest. So that's the other problem, is that systematic reviews take a lot of labour. I think a lot of us will have personal experience of that. Next thing is they go out of date. So the length of time between actually undertaking the search and the results being published can vary. Again, previous researchers estimate that anything between 8 months and 22 months. So that's the time it takes to screen all those titles and abstracts, to get the full text, to extract data, to synthesize it, to write a manuscript, submit it, wait for a journal then to get back. Sometimes if it doesn't get accepted first time, it can bounce around a few different journals and finally gets published. So even on the day it's published, quite often reviews can be anything from 8 months to almost 2 years out of date. And of course, that's a problem because the number of articles which are being published every year is just increasing and increasing. So this is a bar chart showing articles which are related to health inequalities and primary care. So it's a PubMed search. And you can look, back 10 years ago, so in 2013, it's just under 3,000 articles being published every year, looking at primary care and inequalities. Last year, that was over 8,000. So in the past 10 years, there's been almost a 300% increase in number of articles being published. So doing a review now compared to 10 years ago is a totally different task. Yeah, I still remember when we worked, when we started doing our reviews in NICE, actually we did want to try and find every single article on that topic to include in a review. Now, it's becoming increasingly difficult to find every single article, and it's becoming less and less useful chasing down every single article, when in fact, quite often, if we have a body of literature, it's good enough to inform decision making without having to identify every single article out there. So those are some of the main problems, that they take a long time, they're labour intensive, they go out of date, and they're becoming more and more unmanageable. There's other challenges. So we know that reviews are of mixed quality. single reviewer articles miss about 13% of suitable articles. If you double review, they miss less, but they still miss articles. We've also got this challenge where the systematic review literature or methodologies moved on quite a lot. Again, 15, 20 years ago, there was a lot more reviews of single drugs and single conditions, a lot more easy to do, clear cut inclusion exclusion criteria. But now actually the types of questions which we're expecting reviews to address are becoming more and more complex. For example, they're dealing with often complex health service delivery models of care. And so it's becoming increasingly difficult to identify those types of studies. So those are some of the challenges which exist around systematic reviewing. And certainly I feel it's the days of us screening titles and abstracts are numbered. And that's because of the advent of computational methods, which can do a lot faster. So in terms of opportunities for machine learning, so there's two main ways which are out there. One is around text classification. So that's essentially sorting articles into categories. So it could be these are randomized controlled trials and these are non-randomized controlled trials. Or it could be these are to do with inequalities or not inequalities. In reality, it doesn't tend to be a binary categorization, but rather a probability, X probability of being an RCT versus not being an RCT. There's also opportunities in terms of data extraction. So this is identifying snippets of text. And there's certainly ways of, for example, training ChatGPT to extract data from articles to do some data extraction. I'm going to be focusing primarily on the first one, the text classification process. I'll talk you through how we've done that. The data extraction is something that we're working on for the next steps, but I'm not going to cover much of that today. So I'll just take a few moments just to run through how we do the text classification within our evidence maps. So what we started off with was a set of training material. So that was a set of articles which we're interested in. So to do that, we used our equalize study. So this is this NHR realist review on interventions in general practice which address inequalities. It's published last year, and within that was a realist review, but we went through a similar process to systematic review. So we started off by trying to identify systematic reviews. So we screened just under 8,000 articles. We included 251 reviews from those 8,000. And then we unzipped those reviews and we looked within the primary studies of those reviews. So we did that way because we had so many potential articles to look at. So we first of all looked at systematic reviews and then unzipped those systematic reviews and looked at the individual primary studies. And so essentially that meant, think about the first stage of that, we had about 8,000 articles where we made a decision of either this is something we're interested in or it's not something. And we had 251 studies, which were the studies where we were interested in. So that gave us training material to start training a machine learning algorithm. What then happens is those training documents are then vectorized. So essentially that is applying a binary classification to different words within the title and abstract of those articles. And they talk about using this bag of words approach. So I'm going to give you an example of what that actually means. So this is this bag of words approach for randomized controlled trials. So this is if we were trying to identify randomized controlled trials within our living evidence map. If you look on the right side, you can see the manual labels. So relevant 1 means yes, we are interested in it. 0 means we're not. And essentially, what the statistical package does is it looks at words within the title and abstracts, labels them as either 1 or 0, and then compares that with whether we've included them or not included them. Here in this example, you can see, for example, 3 articles, 1, 2, and 3, different words which are used, so ramapril, random, randomized, range, etc. And can see actually within some of them, randomize is is coded as a 1, so it is relevant for the first 2, but not for the third one. So essentially, we create these bags of words for each article, and this can go on for thousands, tens of thousands, depending on the size of the training material. Then essentially it's just applying some regression techniques. So that's either standard statistical regression or more neural network approaches, kind of machine learning way of layering regression. And that produces then coefficients. So we can understand, or we can see what groups of words or bags of words are best suited or align with our more relevant articles. So those coefficients can then be used on a whole different set of articles. So we start off with that set of training material. We then vectorize the title and abstracts of each of them using this bags of words approach, which labels them as 1 or 0, and then creates coefficients for each word. And then that can then be, these coefficients are then learned or used from the training set and applied to a whole new set of documents. And that means that set of documents, we have a probability of that document being similar or not to the training documents that we've used. And that means that we can then priority rank a whole new set of documents. So it means that we can then look through 50,000, 60,000, 100,000, 200,000 articles and very quickly identify the ones which have the strongest association with their training materials. But to present that in a different way, in a traditional screening way, you know, that I give you that example of the 77,000. You would normally screen through those 77,000 and there'd be included studies at various points. With this priority screening process, essentially, we're pulling all the articles which are most similar to our training material to the front of the queue. And so that means we only have to screen a few hundred to start identifying lots of relevant articles. And articles at the bottom of the pile are much less likely to be relevant. So this is the whole idea of priority screening, and this is how we're using it to create our living evidence maps. Like in reality, it's not quite like this. It's more like this, where we can priority screen hundreds of thousands of articles and pull the studies which we're most interested towards the top of the pile. Another way of showing this is thinking about the kind of area under the curve. So the grey line in the middle shows that, you know, as we start screening, the number of articles we identify should be, you know, if we're just doing it randomly, as a traditional review would do, then as you get towards the end of all your screening studies, you should be identifying all your studies in an equal proportion. And that's what we would quite often do. Like if we wanted to, certainly what I've done in the past is if you wanted an estimate of how many studies you'd include, you would screen the first 200 or 300, and if you got 10 or 20 articles, then you could scale that up and think, okay, if we keep doing this for 2,000 or 3,000 or 7,000 or 8,000, then I could estimate how many articles we'll end up with in the end. The whole idea of priority screening is actually we only have to screen the first 10, 20, 30%. And actually by that point, we've included most of the relevant articles. Obviously, that depends on how good the training material is, and how closely it aligns. But that's the whole purpose, is to try and maximize the efficiency of the screening process. So that means actually we can screen hundreds, thousands. It means that actually we can screen thousands, if not millions, of articles in a matter of a few minutes, rather than to prioritize them. And that means that we only have to screen the top few hundred, rather than the thousands and millions underneath that. And this means it transforms how we do systematic reviews. Like, while that process is quite convenient for doing one review because it saves us a bit of time, actually it's not that convenient, because we still have to train that algorithm and hone it down, just to build in the efficiencies. But it becomes very efficient when we're wanting to do the same review on a regular basis to keep something up to date. And so that's what we've been doing with these living evidence maps, is that we create these maps, and every month we can then update them, so that algorithm can rerun. It can then be recalibrated to be more accurate, and it means that these evidence maps are kept up to date, so they're living in that sense of stuff, in the sense of the word, so they don't go out of date. And actually, it takes a bit of human interaction to keep them up to date, but actually, that means that they're living. They're also particularly good for fuzzy topics. So what I mean by fuzzy topics is topics where the inclusion and exclusion criteria are a bit more vague. So if we're looking at questions such as, does drug X work for condition Y, they tend to have quite clear inclusion and exclusion criteria. And so actually the efficiencies which are built for those kind of reviews are less favorable. Whereas if you've got fuzzy topic like we're dealing with around primary care and inequalities, then actually it means that we can cover a lot of different topics and areas within one model, and we can keep that up to date. So that's where this priority screening works particularly well. So that's one part of it, is this priority screening, where we essentially vectorize titles and abstracts, create coefficients, train a model, and then apply those coefficients to hundreds of thousands, if not millions, of articles. What we also do is we complement it by network graphs. And I'll just explain a bit about how we add in the network graph searches. So again, as most of us will be aware, if you do a traditional review, you identify your electronic databases, Medline, Embase, Web of Science, Cochrane, whatever databases you plan to use. And then you do multiple searches of those data sets, of those electronic databases. You combine them, deduplicate, and then you start screening. There have been for a few years some open source repositories. So one was Microsoft Academic Graph, which was Microsoft's way of trying to pull together all the academic literature out there in one place. Microsoft stopped producing that in 2001, 2021. In 2022, OpenAlex came on as a replacement for Microsoft Academic Graph. That's more akin to something like Google Scholar. So OpenAlex catalogs all the research outputs in one place. At the minute, it's got about 240 million papers, and it adds about 50,000 every day. So it's one single repository of research articles, and it pulls in from PubMed and Crossref, but also from institutional databases as well. Now, the big advantage of using OpenAlex, or it would be Microsoft Academic Graph, is that they have forwards and backwards citation tracking and related articles. So many of you may be familiar with the idea of forwards and backwards citation tracking. So we would occasionally do that in systematic reviews. It's where you've done your search, you've got your group of included studies, and what you then do is look through the citations, the kind of reference list of all included studies, to see whether you've got any relevant articles in there. And And you can do it the other way, where you then have a look to see what other articles have cited this paper and could they potentially be included. This whole citation tracking backwards and forwards has been around for a while, and it's fairly easy to do. OpenAlex, as a number of other software companies have also got related articles. So they've created graphical relationships. So based on the text within title abstract, they found similar articles. So this is something which is relatively new in the past few years. Like you might have seen it when you go and find a journal article, it comes up with their citations, but also comes up with related articles. So OpenAlex has got these related articles, and there's up to 20 per article. But that gives us another way of then trying to track relationships. Any of you who've used Research Rabbit will have played around with this kind of method of citation tracking and related articles. So Research Rabbit is another software that does that for you. So if you've got a set of articles which you're interested in, you can plug them into Research Rabbit, and it'll show you all the associated articles, both in terms of citation, but also in terms of similar topics and also similar authors. So what we also do is we also supplement our priority screening with these network graph searches, so that's citation tracking and related articles. So using those two methods, priority screening plus network graph searches, it means that gives us this list of studies which should hopefully cover most of the relevant studies. So just to summarize how we do all of this. So first of all, we identify training material. We did that using equalize. We then use that material to train an algorithm based on the coefficients of this bank of words methods. We then use that algorithm on OpenAlex, which is searching through 200 million records with those coefficients. And that gives us a priority list of articles. That's then supplemented by the citation tracking and related articles from OpenAlex. And that gives us a list of articles which are most similar to our training material. We then just have to screen the top few hundred, and we stop at the point where we start getting saturation. So when we stop finding anything new, then we stop. We then at that process we then apply labels to them, and those labels then form the basis of that living evidence map, which I showed you initially. We then do that every month, so we recalibrate the algorithm. We then add any new studies, and so this becomes a living evidence map. And then what we do as a research team is we then translate that evidence map into evidence briefs, and I'll tell you a bit more about that. So what I'm going to do now is I'm just going to stop and give you a quick demonstration of this in action. This is what the living evidence map looks like, which I showed you. So it contains all of the systematic reviews and related to primary care interventions in disadvantaged groups. Refresh that. I want to just show you what the reviewing process looks like. So I'm hoping this isn't logging me out. So we use a software package called EPPI Reviewer. So this was produced by the EPPI Centre GCL. And essentially, we can, in our screening pile, which goes on for 50, 60, 70,000 articles, which we'll never get to the bottom of it. But essentially, we screen through the first few hundred. So this is the top of the pile. We essentially look through this article, decide whether we want to include it or not. If it is included, then we apply some codes to it. So we decide, is it related to risk factors? Is it related to a specific health condition? And what aspect of disadvantage does it relate to? Ethnicity, socioeconomic position, whatever. So we do this after looking at the field. So if we want to include this, we then pull the full text article and then we apply a code to it. The codes are then what make up these living evidence maps. So let me just pull it up again. So those codes then relate to each of these different disadvantaged groups. It means that we can cut it in lots of different ways. So if we're interested in ethnicity and screening, and we can see that there's 19 articles, we can click on that, and it'll give us the 19 systematic reviews within our evidence map. And then what we've done is we've built a website called the Health Equity Evidence Centre website, which contains all these maps. So within this website, we've then got our evidence maps. So this is going to be open access. We're going live on Wednesday, and it's got a series of different maps for anyone to look at. So it means anyone in the world can have a look at our evidence maps. So it's a really quick and efficient way of finding a series of articles. At the minute, we're just included systematic reviews and umbrella reviews, but we've started looking at including primary studies as well. That's the next step. Obviously, for the NHS decision makers, the evidence maps, while useful, it's actually quite a lot of work to take the 19 systematic reviews and turn it into something useful. So what we're doing is we're producing evidence briefs. So here's 3 evidence briefs we've got at the minute. So for example, there's one on cervical screening, one on cervical screening, and within this evidence brief, essentially what we do is we outline some of the challenges, but then we give a summary of the evidence from the evidence map. We top it up with anything else we find from the great literature and primary studies, and it kind of goes through what works to address inequalities in cervical screening, with some recommendations for the NHS. We're handling evidence slightly differently within our evidence centre. So instead of traditional review, where you end up with a research question and you only include studies related to that research question, which quite often ends up with, we found 2 studies, more research is needed. What we're trying to use is the idea of transferable evidence. So we may not have evidence on cervical screening for one specific minority ethnic group, but actually we've got data from other minority ethnic groups. So let's build that transferable evidence into our evidence-informed recommendations. So it means that we don't end up with this idea that more research is needed, but we try and use as much transferable evidence to build up evidence-informed recommendations as much as possible. So it means that actually in time we'll end up with a library of evidence briefs covering a range of topics from those living evidence maps. On our website, we've also got some other stuff, and I'll put a link to the website for people who are interested in playing around with the maps as well. So this website goes live as of Wednesday, but I'll put a link for anyone who wants to look at it before then. And we're planning a whole other series of evidence briefs. So we've got stuff on digital and telephone triage, on primary and secondary care interface, on physical health checks for SMI. So that's our immediate next steps. We're then looking to expand into primary studies over the next, I guess, 6 to 9 months. We're also looking at the automation of labelling studies. So we're working with EPPI Centre to see the extent to which we could then create suggestions for how each study should be labelled. So that's some other work we're doing with the EPPI Centre. And obviously this has the potential to expand into other areas as well. So we know that there's people interested in doing something similar for public health interventions, but actually the potential is fairly endless. So that's an overview. Like my feeling on this is that actually this is the future of evidence synthesis. That actually the days of us screening manually titles and abstracts of thousands of articles are numbered. I really do think that actually in time we'll all be using some kind of machine learning software or technology to navigate what's going to be an increasingly a large quantity of research evidence. So I really feel it's imperative for us as a university institute to get ahead of the curve with this. Certainly the people we've spoken to in the NHS think tanks and government are really excited and interested about this whole idea of building evidence maps. It makes us much more agile in terms of responding to requests. So it means that actually we can turn things around in 4 to 6 weeks rather than 8 to 16 months. So I think there's lots of advantages. Anyway, I'm going to stop there, and I'm happy to take any questions or comments.